Welcome to this explainer. Today, we're diving into a massive shift in how we build software. We've gone from painstakingly typing out every single line of code by hand to having AI agents spin up thousands of lines before we've even finished our morning coffee. But, with that mind-blowing speed comes a pretty hidden danger. So we're going to look at exactly how to manage that and transform chaotic coding into scalable, secure architecture.
So look, AI lets us crank out code like never before, but there's this trend right now called vibe coding. It's when you just give an AI a high-level intent, a vibe, and let it run wild. Sure, it feels incredibly fast, but honestly, it's an illusion of speed. Because if that AI hallucinates without rigid controls, it doesn't just make a tiny typo. It spits out 1,000 lines of functionally broken logic that your team now has to debug. And that is exactly why vibe coding is absolutely not the same thing as actual, intentional production-grade reliability.
Here's our blueprint for today. We'll be walking step by step through the spec-driven development methodology, from shattering that vibe coding illusion all the way to setting up zero-trust security guardrails.
Let's jump right into our first section and really unpack this vibe coding illusion to build the foundation for our entire approach.
What's really fascinating here is that we have to stop treating AI like a glorified autocomplete. It's truly evolved into a hybrid team member. Think about it. The large language model acts as the brains to reason through problems, but it also has actual tools acting as its hands to execute tasks, like browsing the UI, writing test cases, or merging code in Git. Because it has hands, giving it a vague vibe instead of a strict blueprint is basically asking it to guess. And guessing, well, that's exactly how things go terribly wrong.
Okay, let's move on and talk about the massive mindset shift required here, evolving from a code bricklayer into a technical architect.
This illustrates perfectly how you need to direct your AI. You have to put on your architect hat first during project scaffolding. You're building the skeleton, ensuring a structured foundation. You literally tell the AI, hey, do not code yet. You make it define the rules, propose the folder structure, and set up the tech stack first. Only after that foundation is rock solid do you switch over to the builder or implementer mode, where the AI finally writes features that match your established style patterns.
And here's a crucial tip during that architect phase. Always use strict version numbers for your tools and libraries. If you don't anchor the AI to specific versions in your requirements, it's going to confidently suggest outdated tools based entirely on its historical training data. Models have a knowledge cutoff, right? So if you leave it open, they default to whatever was popular when they were trained. Always double-check those version numbers.
Right, let's get into the technical weeds a bit with our third section, building the anatomy of a perfect spec.
Now, this data is super interesting. It proves exactly why we need to avoid the JSON format tax. Look at this. YAML is significantly better for complex configurations because it relies on clean indentation rather than all those heavy brackets and deep nesting. That makes it so much easier for the AI to read, peaking at almost 52% parsing accuracy. If you're forcing heavy JSON inputs, you're essentially paying a reasoning tax that just burns through your AI's attention and, frankly, your development budget.
So, to reduce token consumption during those multi-turn agent reasoning loops, you've got to treat formatting as a strict, literal budget. Every single space and new line costs processing power and money. The pro tip here: anchor the AI's attention efficiently using simple markdown headers and completely flatten out any nested YAML data structures. A hybrid approach is absolute best. Use clean markdown for your narrative instructions and flat YAML for structured data. It keeps your agent on highly cost-effective rails.
And here's the exact workflow for organizing this. I highly recommend writing your initial technical plans in a collaborative space, like Google Docs first. Have a human review it and catch logic flaws before the AI generates 1,000 lines of code. Once it's reviewed, simply export it as Markdown and drop it straight into a dedicated local specs folder right inside your project repository to anchor your agent's attention.
This brings us to behavior-driven development, or BDD. By using the given, when, then structure of Gherkin syntax, you completely eliminate ambiguity. You're turning user needs directly into strict code requirements. For example, given a user is logged out, when they click the cart icon, then prompt a login screen. See how that forces the AI to think in terms of state, action, and outcome? It completely stops the agent from guessing when it's building production code.
Okay, moving right along to section 4. Let's talk about managing your crew and directing your AI agents.
If you want the AI to avoid losing the plot through context fragmentation, you have to manage its memory. Think of it like a strict hierarchy of configuration files.
You've got a global profile for your universal preferences, a shared multi-tool config so your entire team stays aligned, and finally, a local project spec that acts as the absolute source of truth for that specific app. This keeps the context incredibly clean.
Building on that structure, you can automate constant maintenance tasks by using a dedicated agent skills folder. You literally teach the agent engineering habits. For instance, you can store a repeatable workflow for docs maintenance in there. So when code changes are detected, a skill file tucked in that folder triggers the AI to update the changelog automatically. No human prompting needed. It's kind of like having a dedicated librarian working in the background on your team.
To avoid rushed or incorrect coding, you also need to explicitly define different AI execution modes. The agent needs to know exactly which hat it's wearing. We talked about the architect and the builder, but there's also the forensic specialist for bug fixing, where you provide server logs as evidence instead of just saying, it's broken. Then you have the author for documentation and the librarian for data tasks. Just tell the AI which mindset to apply.
All right, let's look at the cultural impact. In Section 5, scaling these AI workflows across massive engineering teams without causing gridlock.
When you've got tons of agents handling different project modules, maintaining team alignment is tough. Approval fatigue is a real burnout risk. People just start blindly clicking approve because of the sheer volume of pull requests. To fix this, human reviewers really need to leverage automated tests for conditional LGTMs, looks good to me, approvals. Plus, you have to strictly divide work and file ownership by API or UX to prevent agents from overlapping and overwriting each other's files.
Finally, let's dive into our last section, setting up zero-trust security guardrails, because we definitely need safety nets at an enterprise scale.
At full enterprise scale, you absolutely cannot just dump a million lines of code into a context window. Instead, you ingest your system into a knowledge graph database. This feeds into a sub-agent pipeline, allowing the AI to trace exactly what breaks if a specific module changes. It gives you a clear map of the impact instead of a confident guess, safely reviewing massive code bases without hallucinating.
And check this out. This is called context hygiene. To stop the AI from guessing and leaking sensitive data, we have to use placeholders to sanitize our prompts. If an agent lacks data during a test, it might panic and pull real, hard-coded email addresses from its context. But if we use a dynamic context resolver to translate placeholders into safe testing assets, we ensure the agent never accidentally blasts an email to your real user database.
For safer code production, you've got to implement strict automated guardrails. First, restrict the agent to ephemeral terminal sandboxing. That means even if it generates something malicious, it executes in a temporary container completely isolated from your network. Second, use policy servers. And third, mandate human-in-the-loop checkpoints for anything high stakes. The AI does the heavy lifting, sure, but a human must hold the keys for infrastructure changes. Because here is the bottom line. LLMs are probabilistic, not deterministic. If we rely on vague vibes instead of flat YAML structures, strict version control, and dynamic resolvers, we're leaving the door wide open for unpredictable behavior. As the quote on the screen says, guessing is how rogue agent incidents occur. We absolutely cannot afford to let them guess in an enterprise environment.
I hope this explainer has given you a solid blueprint to master spec-driven development. The bottleneck in software engineering is no longer code production, it's system design and integration. So my question to you is, are you still writing code, or are you ready to step up and architect? What structures are you going to build next with your new AI team members?